Hello and good afternoon. I'm feeling a little bit under the weather today, so excuse me if I will have a runny nose during our conversation. The title of today's talk is Mapping Reality. What do we mean when we say mapping reality? What comes to mind? Well, several terms, and especially today we have mapping because of the information technology applies on so many levels and in so many situations. But let's make a few examples. Let's start from simple concepts. When we say house, tree, the sun, what we do, what we are doing. Of course, there are several theories, several discourses about that. But one way of looking at it is that we are, just like little kids do in school when they say B, the letter B, and then there is the image of a flying bee. Okay? We do the same thing when we say house, tree, sun. We do basically the same operation. We establish a one-to-one connection between the object and the word. But the word is also what? The word represents also a concept. Now, this type of mental mapping happens everywhere. Every relationship between a class A and a class B, meaning the class of all houses. Just by adding an S, we create a plurality of objects. It recurs to infinity, if we want. The classes of trees. Well, the sun is just one, but what could you do to create a class applied to the sun? You could say stars, because the sun is a star, is a B-class star. Now, this process, this operation that associates each element of a given set, called the domain, with one or more elements of a second set, is a classic mapping operations. Now, we should probably go a little bit back and talk again or more about the concept of mapping, because mapping implies then what? When you think of mapping, you think immediately about a map, right? So a map implies the concept of relationship. Which relationship is this? Is the one-to-one relationship, where you have object A. You would say it like this. You would say a set of object A, B, C, D, etc. mapped to another set where we have house mapped, in this case would be the object house mapped to the word house, therefore to the concept. Now, it might sound strange to some, but even our concept of truth in contemporary society depends on this idea of establishing relationship. That's why Aristotle, the formulation is not his, it's not coming from Aristotle, but it's a later reference, it's a later formulation from the scholastic thinkers. Aristotle used to say, or I mean, I rephrase it. Aristotle defines truth as adequatio rei et intellectus, which means a relationship between the thing and the intellect. Therefore, this is a house. So the thing is equal, rei equal house. I perceive the reality of the house I'm calling house through the intellect. Then this equivalence between rei, the thing, and the intellect, the mental faculty that establishes the relationship, I call it truth. If I would say sun, and I would say house, this relationship, because in this case, instead the rate being the house, the rate would be the sun, this relationship would be equal, false, or unequal, not true, right? So from that, we determine and define our concept of truth as well. I mean, the general concept of truth, because the truth relationship is a complex philosophical problem that in modern times has given a lot of trouble to many thinkers, to the point that we prefer to avoid the topic. And one of the reasons why we avoid the topic is because when you see it this way, truth becomes what? Becomes a construct. Meaning, truth, it's not, as Jefferson would say, influenced by Locke, a self-evident truth. It's not self-evident, but becomes a relationship that depends on our mapping of reality, therefore, on many other factors that are subjective, the person seeing that. If I'm colorblind and I would say this is green. So you would say, okay, this relationship, this with green, the pen, equal. Green is equal false. But for the colorblind, it's equal true. So we would say truth depends also on the perception, depends on the language. That's one problem where Wittgenstein stumbled upon when thinking about the relationships that you can establish. He came out with the concept, saying the concept of ostension, meaning this is not the sun because I called it sun, but it is the sun when I point at it and I say sun. He wants to get rid of the linguistical somehow of the, or to have a more stable foundation of these referential connections. And of course, this is also problematic because I say water. We would say in the United States, water. But if you go to Germany, they would say Wasser. So Wittgenstein said by pointing at water, I avoid the linguistical issue, but that would be like going back into a pre-linguistical thinking or concept of reality. And we don't have that. We have a reality that in many senses is based on the concept of relationship. If you think, even mathematics, that it seems the more abstract and based of human disciplines, when you go on the basics of mathematics and you start thinking, what is a number? This is a fundamental concept in mathematics of which there is no demonstration. Where, if we start to imagine, where does the concept of number come? Where does it come from? Well, the theories are many. But with a reasonable, reasonably, we can say that there was a point in history where mankind didn't have the concept of number. So where does the concept of number comes from? Try to imagine a shepherd 10,000 years ago, 15,000 years ago, 20,000 years ago. This shepherd has 3 sheep. 1, 2, 3. That's easy, right? Because he doesn't really need to count because he has fingers, so he can use 2 hands, 1 hand, whatever. Until 10 sheep is fine. You could say he can do 20, like he can use his knobs. There are actually mathematical systems that are based all on the bones of the hand or on the teeth, etc. But the point is that when he has 800 sheep, 1,000 sheep, yeah, what is going, and then he brings them out to go eat in the morning. When they come back, how does he know if the sheep are now 999 because a wolf got one on the way or because one got lost, etc.? A lot of ancient stories are full with shepherd going back to find the lost sheep, right? Now, how does he do that? Well, one theory, which makes a lot of sense, is that before the animals leave in the morning, he would put one little stone for each animal in a little bag. So, sheep 1, stone 1, sheep 2, stone 2, without calling them 1, 2, 3, but he knows that to every sheep corresponds a stone. So when he has here 1,000 stones, 1,000 sheep are outside. When in the evening they come back, he takes the stone in his hand and he starts putting them back in the bag. If 1 or 2 or 3 stones are out, means that 2, 3 sheep are out. It's a very simple way, and we have roots of that even in terminology, in words. If you think that the word for calculus in English means in Latin stone, little stone. So there is even a connection, a linguistical connection to that. But what we are interested in here is the relationship that the ancient shepherd places between sheep, stone, and number. Here is where number starts. That's also one reason why the number 0 was not seen as a number for millennia of our history. The invention of the 0, which is fundamental for modern mathematics, is something that didn't exist until a few centuries ago. The Greeks didn't know the 0, and the Greeks were extremely the people that basically invented modern mathematics. But they didn't know the zero, because the zero is to them was a non-number, a nothing, a non-stone, something that cannot be computed, something that cannot be calculated. How many non-stones should I have to put in the bag? And the Greeks actually had kind of horror for another concept, that is the concept of infinity. So two of the most important concepts of modern mathematics were strangely unknown until recently. It's just with Giuseppe Peano, an Italian mathematician recognized by Bertrand Russell, that we officially acknowledged the existence of zero in mathematics. That's why our arithmetic is actually should be better called Peano arithmetic, because it's Giuseppe Peano that formalized it, and the first axiom of Peano is exactly that: zero, zero, numerus est. The zero is a number. And why we are going that far? Because we understand how fundamental, or we should understand how fundamental is the concept of relationship into mapping reality. But also, and this is mostly our topic, into mapping knowledge and understanding of it, which would be the second step. Let's go a little bit further. Let's leave the relationship there. Let's see the concepts that are for us fundamental. I would say the transaction between sheep, stone, number. Now, there is a very important thinker who was a great Polish scholar. His name is really difficult to pronounce in Polish. I would say that in English, but Alfred Korzybski. And Korzybski came with a very important concept. A map is not the territory it represents. The sentence goes further by saying, but if correct, if the map is correct, it has a similar structure to the territory, which accounts for its usefulness. You see how clever is Korzybski. While he's not talking about truth, but reality, he's talking about usefulness. Because a map is not the territory. That brings us back immediately to the famous story of Jorge Luis Borges, when he was talking about some cartographer of an imaginary state that were trying to map the territory in the most accurate possible way. And these people came up with the idea of creating a map as big as their country and then as an entire planet. Meaning a one-to-one representation. Meaning if we walk in this territory, in this imaginary territory in the story of Borges, we would walk over the map of the territory. This is a paradoxical example in the way that Borges makes it to prove or to show how paradoxical is the concept or the idea of being able to map the territory one to one in a absolute manner. Therefore, a map is not the territory. A map can be useful. And then this brings us back to the beginning of our little conversation here, where we made the relationship between language, house, and the word house. Now, if we keep in mind these ideas that we explained so far, we understand, or we can rephrase that in what way? We can say the language is not the house. The word, I would say in a better way, the word is not the thing. It's not. We should probably open a digression on this, that mankind for millennia has been fascinated by language, and language as for millennia had magical powers. Remember all the stories of the tradition, of the magical, mythical traditions, the doors that open through words, enchantments, the famous abracadabra. And a lot of this games, because we should think that the invention of words, the invention of the identification between a thing and the word has been for our ancestors something extremely magical, because suddenly allowed you to communicate with others, or allowed you to point at things, to transmit wisdom, to transmit knowledge. And that brings us always back to this topic of knowledge. How would you... All right, let's get rid also. Do you remember another famous statement that would bring us... Oh, well, I deleted the word is not the thing. Okay. The word is not the thing. Do you remember, or can you come up with an idea, or with an example where the word is not the thing could apply? I'm sure that everybody knows this famous sentence. Ceci n'est pas. This is a sentence that means it's French, is not a pipe. And this is written on a famous painting by Magritte, a French painter. Unfortunately, in the painting, there is a pipe depicted. The word is not the thing. That this would translate exactly like that. Now, another example on this would be a very ancient example from the Buddhist tradition. And it's called The Blind Man and the Elephant. Now, there's a story where there is a bunch of blind men that are touching an elephant. Each one, by touching a different part of the elephant, will perceive or understand something different. The one who is touching the belly of the elephant would say, here there is a wall. The one who is touching the legs, he would say, here this is a column, this is a big column. The one who is touching the tail would say, this is a big snake. The Buddhist example, myth, story, exemplify once again not just the fact that the words are not the thing, but that sometimes the reality itself is not the thing. How do we mean that? If you ask a physicist today, is this solid? What would the physicist answer? The common person would say, of course it's solid. Look, you can knock on it. The physicist would say, no, it's not. It's not solid. The physicist could say, you are like one of the blind men looking at one side of reality. Because if you look at the real reality of this whiteboard, you will discover a very simple quote unquote, law of nature. Everybody remembers from school the very bad representation of the atomic model. And it's an example, again, not just the word is not the thing, but even the image is not the thing. See? Word. Here I'm going a little bit further, establishing a relationship between word and image, which is what Magritte used to help us with. Now, the physicist would tell you that here there are protons and neutrons. They are the particles that composes the atomic core. And these particles here are electrons. If you ask a person and say, okay, let's imagine that the atom, the nucleus, is as big as a fist, a human fist. Where is the electron going to be? How far is the electron going to be from the core? Now, people that don't know physics, but they are trying to give a reasonable guess, would say it's 500 feet, a mile, 10 miles, 100 miles. But nobody would tell you this is going to be 600 miles, 800 miles away from your fist. Nobody would say that, unless they have knowledge of physics. But physics tells you exactly that on the atomic level, in the atomic world, emptiness, and there are a lot of very good reasons for that, is way more than what is filled. Actually, very little is filled. Large part of what we call matter is basically just emptiness. So this brings us to the understanding, the deeper understanding that makes you see not just beyond the words, not just beyond the image, but even beyond matter. Now, how can we apply these concepts to a mapping of reality if the mapping of reality doesn't seem to be possible? Well, what do we know is that even if it doesn't seem to be possible, which is one of the consequences, for example, of quantum mechanics, of the quantum theory, saying you will never be able to know all parameters in a system. You will either know one or the other. So we said it cannot be exactly mapped, like nothing can be exactly mapped, exactly put in terms of a one-to-one relationship between a thing and the idea of it. But, and this is a very important big but, could a mapping of reality, even if the word is not the thing, the image is not the thing, the idea is not the thing, could still be useful. And now this will bring us to a very different aspect of it. Let's say I want to create a map of history of mathematics, or history of physics, history of logic, history of philosophy, or history whatsoever, history of my family. I want to create a map. How can I represent a map like that? So most people, like you see a lot online and in books, would create what is called a timeline. Timeline would be, here is year 0, here is year 50, here is year 100, etc., etc. Here happens X, Y, and Z. Here happens A, B, and C. Here happens... So they will basically do what? Create a bucket where you put all this data and you use time as a way to give a symmetry or to regulate this fact into an order that we call chronology. See, words have their own wisdom. Chronology, it means the logic of time. Chronos, it means time in Greek. So the reason of time, the logic of what time can impose to facts, because this is also how we perceive things. We can go back to Aristotle, who, using a similar argument, he gave the first definition of time, saying time is the number of movement according to before and after. I'll explain, even if it sounds difficult to grasp. Time, T, is the number, let's say 10, of movement, so it's a movement on a line, between before, past, and after, future. This is 10, this is 9, this is 11. Aristotle says this is time. Time is basically, according to Aristotle, not according to us today, a simple progression that he identified with a numerical progression. This is the present, sorry, I forgot the present. This number here is the present. Of course, this is extremely generic because then discussions on the present, what is the past, what is but this is a representation, a linear representation of time, which is used as well in our images of chronological representations. Then some creative artists do things like they will add different colors here and make it here this happens to show that this event, for example, is a single event and doesn't, I mean, you can extend this to add more time. If you would say this is a European chronology, then you would have here the African chronology, you have the Asian chronology, and then you can make color relationship between those chronologies, etc. But this is still a static mapping, which will give you some insight, yes, would give you some, if you go, for example, you have here Asian and European chronology, you would say, here's about the 6th century before Christ. So you would have here Confucius, you would have here Lao Tzu, and you would have here Thales for the Greeks and all the Heraclitus. And then you would have here, in the 5th century, you would have the ethical thing. Actually, Confucius would be more here, sorry. Here would be Lao Tzu. Anyway, you can see also some parallels, which are extremely interesting for the study of history between cultures that apparently have been taught by us to be very far and not related. But apart from that, it's just a static mapping. You cannot really navigate that mapping. It's there. You read, in some cases, if you already know those events, it becomes boring. But today, information technology allows us to have different types of mapping for what I call knowledge maps. Now, a knowledge map for me is different than a simple chronology. It's very different. How is that different? Let's make an example. Well, examples could be many. But we can start. I don't know, I would like to start with, from what point should we start? The natural starting point would be ancient Greece, but I don't want to do that. I want to start from Gottlob Frege. Gottlob Frege was a brilliant German mathematician, logician, and many things, who wrote a very important book called the Begriffsschrift. Why I'm using Frege? Because it's also related to our knowledge map, because Begriffsschrift in German means the history or the writing of concepts. So Frege wrote this very influential treatise. So we use that, we do this. We do a point for Frege, a little dot. Unfortunately, a whiteboard is not a digital plane, so I won't be able to go on all the dimensions you can go on a digital plane, because while those maps, for example, those color maps, they are two-dimensional maps, meaning they work only on the x, y axis. So you have here the image with the color, etc., but it's just bidimensional. While the internet, the electronic, the computer allows you to have points that are in 3 dimensions. So you can have relationships that are not just x, y, but x, y, z. So three coordinates. You can have distance, for example. This could be the same time. This could be Bertrand Russell, and this is Gottlob Frege. And then you can have hot intersection. It's a way more complex structure. But anyway, keeping this in mind, let's think that the whiteboard I have here, it's not 2-dimensional, but it is 3-dimensional. That we have 3 dimensions. X, Y, Z. So this is our board. So what happened here? You have Gottlob Frege that publishes this book in the year 1908, 19 something. And there is another mathematician, another great logician called Sir Bertrand Russell, that writes. Bertrand Russell is in England, Frege is in Germany, so very different point in space. So Russell writes a letter to Frege about the self-referential proposition in his book. Basically, this poor man worked his entire life on this Begriffsschrift, this book, and Russell asked a very simple question. He wrote him a letter, and while the book was getting published, Frege thought, it's all wrong, I'm sorry, I have to throw everything away, because Russell, from which comes then what we call the paradox of the barber, which means there is a barber in a town who shaves the bar, and he shaves everybody that does not shave himself. The question is, who shaves the barber? So it's a self-referential paradox. And Frege, unfortunately, stumbled upon self-referential paradoxes. And he wrote a preface in his book saying, I'm publishing the book because it's already done, but now it doesn't have any meaning because this mathematician, Bertrand Russell, proved to me that there is a flaw, a very deep flaw. Now, I don't want to go too much into Frege, but Frege then abandoned his work, unfortunately, because there is a lot to be understood in this work, and did other things. But the ideas of Frege, influenced by Russell, here there are many other thinkers that we could populate this with so many points, in so many different colors, and with so many reference, etc. So Frege influences are Bolzano's, for example, Bertrand Russell. But one of the most known influences would be, so we have here relationship Gottlob Frege, Russell. We would have here Ludwig Wittgenstein, who, and that it's also related to what we are talking about, taking the ideas of Frege, turned them into a book called the Tractatus Logico-Philosophicus, which tries to identify everything with the facts. That's the first Wittgenstein. Anyway, we don't have to go deep into their concept because it would take here 20 hours just to do that. But the thing is that we are now able to establish another interesting relationship between Frege, Wittgenstein, also Frege, Bolzano. And then there is another relationship that you can take out from this between Russell and Wittgenstein, because the one who allowed Wittgenstein to publish the Tractatus Logico-Philosophicus was Russell, because nobody wanted to publish this book because it was considered to be too abstruse and difficult, and definitely certainly not for not interesting for the majority of academics in his time. But it was published because Bertrand Russell wrote the preface to the Tractatus Logico-Philosophicus. And from that, we can establish more and more and more thinkers who have relationships, direct or indirect, with this story related to the publication of the Begriffsschrift. We could add to a map like that, which would be a three-dimensional map, a lot of other things. For example, you could put here Nietzsche and Schopenhauer. And before them, you can put Kant. Kant influences Schopenhauer. Schopenhauer influences Nietzsche. Max Stirner influences Nietzsche, and Hegel here is influenced by Kant, but does not influence Schopenhauer. But Hegel influences another very not well-known figure of the world history, Karl Marx, who is also together influenced by Stirner. I mean, you can see, and then Karl Marx is influenced by whom? Okay, by a lot of thinkers, by German philosophers like Hegel, yeah, we already said that, by French political thinkers like Proudhon, you can have here Proudhon, but mostly is also influenced similarly from Richard Darwin. You see how, and Richard Darwin influences also Schopenhauer, and influences also Nietzsche, and influences also Stirner. You can define in a map like that a series of relationships based on the connections and the influences that would give you also the ability to go deeper in, you can navigate that through with the computer, and you can ask how many influences there are, for example, between Richard Darwin and Gottlob Frege. How direct are the influences? You can establish a hierarchy of influences. Let's say first level, second level, third level. You have Hegel, Marx, first level, because Marx through Bruno Bauer, which will be in between, was deeply directly influenced by Hegel. You can put here even literature. You can, in a map like that, with that type of relationship based on a three-dimensional model, you can basically map the entire human history of knowledge, because the computer would allow you to go so deeper. You could click there and also redirect it to the digital copy of the Begriffsschrift. You can map again using colors. You can say definitely, well, some of them it would be difficult to give colors, but Nietzsche, for example, or Schopenhauer, you can say definitely philosophers. Kant, philosophers, philosopher, epistemologist, many other things. Hegel, same thing, logician in his own way. But to the colors, to the main color, you can say philosophy is blue, science is red, biology is green. You can add more and more layers. It could be an open map. All knowledge maps are supposed to be open maps. Why? Well, because knowledge is always an open path. Knowledge, that's why I always use the metaphor, the allegory of the forest. I would say all these maps, all this relationship that applies in a three-dimensional space are also something like a forest. A forest where we know that in the forest there is not just one path. Same as in reality. And that brings us back to what? To the fact that the word is not the thing, the image is not the thing, but sometimes the thing is not the thing. If there is a consequence, a very fundamental and important consequence of modern science, is what we call indeterminacy. I.e., we moved from a deterministic model of reality, where to A should necessarily follow B, to event A should necessarily follow event B, to a universe which is not any more singular, but is a multiverse, where to event A you can have an infinite number of outcomes. You would say, well, but in reality, in what we call reality, this doesn't happen. Well, but that's our problem. Like the blind people looking at the elephant, because in the real reality, which, there are no questions to say that the real reality of our universe is the subatomic level, Those are the ultimate constituent of matters, and the interaction that happens there are the fundamental interactions of the fundamental reality. Well, on that level, you don't have this rigidity where to event A should follow event B. This means that a reality has a deeper complexity than we think or we imagine. But we can always try to construct knowledge maps, because even if they are not accurate in the way our dreams would want, you remember in Shakespeare, Hamlet, I could count myself king of infinite worlds. It wouldn't be that sometimes I have bad dreams at night. The dreams of human beings are of an absolute certainty. But the reality tells you that this certainty is not possible on a fundamental level. But every approach through knowledge, every entry point in the universe through a model based on understanding, on knowledge, on a separation from ourself, from our wishes, from our little desires of understanding everything, our little small desire to know, and entering the territory where we should understand, as the great philosophical master and thinker Socrates, we know that we don't know. Well, we would see that an access to reality through knowledge, it's at least more useful than an access of reality through a fake certainty. Thank you.